Okay, in this video, we're going to go over complex numbers, what they are, and then ultimately get into complex number operations, something that you would hopefully have seen in Algebra 2. All right, so quick little reminder about what complex numbers are, where they came from. So essentially what happened many years ago, mathematicians realized that if they ended up having a square root of a negative number, that we cannot actually find a real number that would work for that. So to kind of as a workaround to keep going with the math they were doing, they came up with this imaginary number, this letter I, to represent the square root of -1. So that's why you were introduced to it back when you did quadratics, because sometimes you might get some negative values inside a square root. So this kind of thing here is really important because when we do our complex number multiplication and division, we're going to end up with something called I squared. We'll multiply I times I to get I squared, and we need to use -1 as a real number. So I squared, even though it has the letter I, is actually not an imaginary number. It is a real number, okay? We're going to be looking at numbers in the form here of A plus BI, where A is the real number and BI is the imaginary component. We'll also be using something called the complex conjugate. I'll get more into that when we get to division. All right, so let's try some addition and subtraction. So this is as straightforward as it's going to get today on this lesson. Whenever you have adding or subtracting complex numbers, you're going to add or subtract, whatever you're doing, the real numbers together, and then subtract or add the complex numbers. So in this case, I'm going to have, let me try to zoom in for you, 3 plus 2, which is 5, and then -4i plus a positive 5i, which is positive 1i. And that's it. So again, real to real and imaginary to imaginary. Let's try this next one, subtraction. -5 minus -11 is actually -5 plus positive 11, which is going to be 6, and then 7i minus 2i, which is going to be positive 5i. So that's it for addition and subtraction. Again, just remember to combine the real stuff and then combine the imaginary pieces, okay? There's some practice problems for in class or on your own if you'd like to try them. Let's get into multiplication. So it's a little bit tougher. We are going to distribute like you would do for any binomial times a binomial. Again, this quick little note up here that when we get I squared, just a reminder again, I squared is not an imaginary value. You can go ahead and replace that with the real number -1. So here we go. 3 times 4 is 12. 3 times -I is -3i. 6i times 4 is 24i, and then 6i times -I is -6i squared. So the first thing I do is I always go ahead and replace, once I see that I squared, I replace it with -1. All right, immediately I need to tell my brain, hey, that's not imaginary anymore. You need to take care of that. It's a real number. So I go ahead and, again, I'm still kind of copying pretty much everything here, except that -6 times a -1 becomes a positive 6. And now, kind of like when you did with the addition and subtraction, I'm going to combine the real stuff and then combine the imaginary pieces. So 12 plus 6 is 18, and -3i plus 24i is plus 21i. All right, and that's it for multiplication. All right, now division. Division is going to feel a lot more complicated, but it actually is exactly what we just did with multiplication, except you have two instances of multiplication to do it. So what I tell students when they're learning this is dividing is very similar to multiplying, except you're going to have to end up multiplying two of these that we just did on the previous example. So this is where I'm going to introduce that conjugate. All right, so if we are talking about the standard form of A plus BI for our complex number, the conjugate is A minus BI, and all that means is to make the sign in the middle the opposite. Nothing else should change. And the reason that's important is because if we multiply conjugates together, right, what happens is that the imaginary pieces will become 0. They will disappear. So the whole point of this is we can't leave this I in the denominator because that means we have a radical in the denominator, and this is called rationalizing the denominator. It's a little bit more complicated with imaginary pieces because we are going to have to multiply by a conjugate. So you'll notice we have 4 plus 2i, and I'm going to be doing that to the bottom and to the top. It doesn't matter which one you do first. I like to do the bottoms first, just because the whole point of doing this is to get rid of the imaginary piece in the denominator. So you'll notice when I multiply this out, I'm going to show all the work, but as I do more and more of these, I actually don't show the middle pieces because I know because these are conjugates, they're going to make 0 for my imaginary piece. So here we go. 4 times 4, 16. 4 times 2i is positive 8i. Negative 2i times 4 is negative 8i. Negative 2i times 2i is negative 4i squared. So exactly like I was just doing, right? Again, I know this is division, but really you'll notice all I'm doing is multiplying. I squared is the same as negative 1. Let's go ahead and keep copying stuff down. You may have already noticed what's happening with my imaginary pieces. This becomes a positive 4, and then you should see 8i minus 8i becomes 0. That's on purpose. That should not surprise you. We chose the conjugate of 4 minus 2i on purpose because that makes 0. So 16 plus 4 becomes 20. So this right here is my new denominator. All right, so I'm not done yet, but that's my new denominator. All right, the last piece, or last thing to do, is to multiply the numerators. So 2 plus 8i times 4 plus 2i. So 2 times 4 is 8. 2 times 2i is 4i. 8i times 4 is 32i. And then 8i times 2i is 16i squared. Just like I did before, I'm going to copy everything down. Replace 16i squared with negative 1. Keep copying things down. You'll notice my middle pieces are not going to make 0, right? We are going to have an imaginary piece in the top, which is okay. It's in the numerator. All right, 8 minus 16 is negative 8. 4i plus 32i is 36i. So you write them together. Negative 8 plus 36i over 20. This is the solution, right? Remember, this is my new numerator. All right, this is the solution, but most math teachers or IXL or Delta, whatever you're using, are going to ask you to simplify this. All three of these pieces can be divided by a number, by 4. So if I take negative 8 and divide that by 4, I get negative 2. If I take 36i, divide that by 4, I get 9i. And then 20 divided by 4 is 5. So this is going to be our simplified solution. So again, that was a division problem, right? It says divide. But did we do any division? No, we did 2 separate multiplication of complex numbers. All right, so that's it for complex number operations. Good luck.